In this tutorial, we are going to look at continuous compounding. So the formula for continuously compounding interest is A equals P e to the RT, or PERT, where A is the final amount, P is the principal or the initial amount, R is the annual interest rate, and T is the time in years. So Tom has $44,000 in his checking account. He invests $17,600 of it in an account that earns 4.3% interest compounded continuously. Write the exponential model for the amount of Tom's investment. So let's write the equation. A equals P, which is the principal, that's what we invested, so $17,600. E is our constant 2.7, and our rate is 0.043 times time. So that's our initial model. What is the total amount of his investment after 5 years? So that would be A equals 17,600 e to the 0.043 times 5. So go ahead and put that in the calculator. So after 5 years, Tom has $21,821.57. When will he have 100,000? So again, we're going to put that into y equals, put our original model, and then in the table, go ahead and look for $100,000. When will she have 100,000? Well, we know that the final amount we want is $100,000, and she invested 17,600 e to the 0.043 times t. Now what we want to do is we want to solve for t. But in order to do that, we need to divide by 17,600 so that we have e by itself. So 17,600 in each side, and we divide that, and we get 5.68 equals e to the 0.043t. And from there, we know that we can take the natural log and cancel out the e. So we're going to take the natural log, that cancels out, and that means I take the natural log of this side. So we end up with the natural log of 5.68 equals 0.043t, and then we divide by 0.043 to get t by itself, and put it in the calculator. Natural log of 5.68 divided by 0.043, and we get 40.4. So what does that really mean in years? So 0.4 of a year, let's take 12 times 0.4. What does that give me? About 4.8 months. So I'm going to say it's going to take us 40 years, and I'm going to round up in 5 months. We are going to take and make a slight modification to number 2. So let's look at that for a second. Go ahead and cross off how long does it take her to invest 8,000 to get 10,000. It doesn't go with the problem right now. So go ahead and try number 2, pause the video, and then come back and see what the answer is. So in this problem, we have the final amount equals $10,000 invested times e to the rate, which is 0.062 times time. That's our model. And then we're going to look at when she has 12 years, 0.062 times 12. We'll go ahead and put that in the calculator. And she will have $21,043.36. When will she have 200,000? So we know that our final amount is 200,000, and that's equal to our 10,000 times e to the 0.062 times t. And we go ahead and solve. So we divide by 10,000 both sides. And we get 20 equals e to the 0.062t. And if we take the natural log of e, that cancels out, so we have to take that on both sides. So the natural log of 20 equals 0.062t. Divide by 0.062, divide by 0.062, and our time would be 48.3 years. And I want actual months, so 0.3 times 12 months gives me about 3.6, so I'm going to say I have 48 years and 4 months. I'm going to round. We're going to do some fixes on number 3. Will make this Daniel be able to retire? And then on letter C, how long will it take for Daniel's investment to reach $1 million? So I want to make sure you're talking about the same person. So go ahead and do that one for homework tonight.